Hello, everybody. Welcome to our session today. Before we get started, I just want to make sure everybody can hear me. So if you can, please use the hand raise icon at the bottom left. Okay, awesome. Thank you so much. Um, I'm going to hand it over to me here in a minute, but before we get started, I did want to mention to everybody, we will be having a webinar on April 30th. I encourage everybody to join, especially our users. We will be announcing the launch of our M Collection service, which includes a lot of new integrations, a lot of new services, and also new functionalities that are going to be added. You can join the session scanning this QR code on the screen, but I will also share the link where you can all share, where you can all register using the chat. Um, I just sent it, so anybody who's interested, feel free to click on the link and you can register there. I encourage our users, but also anybody who is new to the software. This will be a really important and information-filled session for you guys. And if anything else, you can also win $100. um, if any of you have already registered, don't worry, you are automatically entered um, to the $100 raffle gift card raffle. Sorry. But yeah, we'll start in about 2 minutes, so I'll give you guys time to take a look at the link I sent over in the chat. Again, feel free to register. I really encourage everybody to join. It's going to be a lot of new information that a lot of you may not have heard of yet, and I think a lot of you have been asking us when we're going to be integrating these functions. So this webinar will give you all of that information and hopefully answer all of the questions that you may have. Yeah, so please feel free to join. And then while we wait for everybody else to enter the existing webinar, I'll hand it over to me here. We will show this page towards the end just in case anybody misses it. But again, the link to join is in the chat, so feel free to go there, register, and then come back. Thank you.
Yay. Thank you, Lucy. I'll take it from here. So, hello everyone. Good afternoon and welcome to today's session where we will be talking about steel composite designing and results part. I'm Hijan. I'm Senior Technical Engineer at Midas Soft, and the first session was taken by Axel Lee, who is our support engineer at Midas IT. So today we'll be just proceeding with the flow that we did in the last session. So just to give you an outline, like what things we discussed. So in the first session, we have seen the pre-processing parts where like we have seen the definition of properties, geometric modeling, static loads and moving loads. So all the model creation and the definition of loads were already done in the first session. Now in this session, we will focus more on the post-processing analysis and results part. So we will be seeing the reaction forces and all these parts. After that, we move towards the steel composite design. So to move ahead, like in the post-processing analysis results part, we will be checking these 5 steps. Like first, we will check the reactions for our bridge that has been received. Then we check the forces and the bending moment diagrams for all the different elements. Then we will see the moving load result, like for our moving load case, how the vehicles are influencing our bridge. And then we will see the moving load tracer. That is an important feature of Midas Civil that is not available in all the programs, I would say. With the help of this feature, you will be able to see what is the critical position of the vehicle that is causing the maximum effect on your bridge. So we'll focus upon that. And we will also see a procedure where you can convert this critical moving load into a static load. So that will be the flow for the first part where we'll be discussing about the post-processing and the analysis results. So for the check of reactions, like you might see, like we already created the model. So basically we first have to go to the results tab and here you will find the reactions. Under the reactions, I will select the specific load case along which I want to check the results. After that, I check the forces for which I want to see the results. So I select FZ, that is vertical reaction, and I check the value and the legend option and I hit apply. After that, I'll be able to see the results in the program. So now we move towards the model to see the same step. Before I proceed, I will just give you some more overview about like how do you see your model once it has been created. So you can see like once the model is created, you have 3D view of all the elements over here like this. From here, you can just have a different control like what is the viewing angle. This is the isometric view, the top view along x-axis and along y-axis. So basically selecting that, you'll be easily able to see the views. And in this work menu, you will see all the definitions that has been done. So as you are seeing, like this is Midas Civil NX, that is an upgrade to Midas Civil. So you will see some small changes and important one from the user interface point of view as well. Earlier in the work menu, there was no search option like this. So if I wanted to see any static load, I would have to go and navigate and then search for that. But now, say I'm at the top, there are a lot of definitions that has been done. I want to see the load corresponding to DC2. So basically we just search here and that will navigate us to that part. And I click display and it shows the values. Another thing for the same is like you can change the intensity as well. So if I change it to Kip's feet, you can see the value of the loading, and using the scroll option, I can just see what is the intensity value. So basically it helps us to increase the text form or any kind of display option. That is another enhancement in the interface part. Once that is done, now going back to our procedure, so we went to the results part and here you will see the reaction. So I check reaction forces moments here. I select the specific load case. So if I'm checking self-feed DC1, I want to see FZ. I check legend and values. I can keep the legend as fixed and then you hit apply and you see the values like that. So this is what I was saying about all the results. In the similar manner, if you want to see the results in the form of tables as well, so you can just click on this three dot option or you can just navigate from here and I select the load case like this and then I check on the option. So you see FZ values that is present here, and these things are easily can be copied to Excel as well. Like I can just copy in this manner or I can just export it to the Excel. And we also have another feature using API, which like we will be discussing more about that in the M collection release. So I will again request you all to like join that webinar, because as of now in this Midas Civil NX version, we are checking the possibilities that was also available in Civil. But when you go to the apps option, you will find this API settings and the plugin options. That is a lot to explore. So that will be showcased in that webinar part. Moving forward, after I check my results for the reactions, next thing I will check is the forces and the moments. So again, to check the forces and the moments, we are having like the results tab, and from here you check the forces here. Then you select the required load case, select the component of the force, select solid fill, that will give you a more graphical output, and then you select the contour and the legend and you hit apply. Here you can see the values as well. So that is the procedure. So we go to the results under beam diagrams. I select solid fill and here is the load case and I click apply. I will check off the values. That will be easier to understand. And here from here, I can just navigate and see the values. So as of now, you can see the maximum bending moment is in element 80. If you want to see that as well, you can just select here and click 80, and that will highlight the 80 element number like that. Similarly, you can check shear force as well for the same. So you have the shear force diagram. Another important thing is like in case you are working and you don't have the tree menu too, like this over here, like the work menu. So earlier we used to navigate by right clicking here, but now you see for the simplicity, it is again mentioned here itself. So if I'm just working with the one tree menu, I will check on this option, while for the extreme two, I can use this part. And here are all the activating and the selecting elements toolbars, while here are the hidden mode and the display options. From here, we can lock and unlock model. From here, we can perform the analysis, selecting nodes, selecting elements. And when we are having different stages, so we can navigate here. And if you are having composite sections for construction stage, you can navigate from here. In the similar manner, like if I'm checking the stresses as well, so I go to the stress option, beam stress diagram. Now, while we talk about the stresses, like if you, in case you are having composite section for the construction stage, you will have two parts over here. So you will be able to see the results part wise for your part one, that is girder, and part two, that is your deck. In this case, I'm checking the total since there are no composite sections for the construction stage. So here you can see the stress values as well in this manner. So basically you can check the stress values at the four location where the minus y plus z, and then plus y plus z, and then plus y minus z, and minus y minus z. Based on the local axis, like here, you can just navigate or you can check the maximum one like that. Again, these stresses are available in the form of tables as well. So as of now, you can see like this is SAX, SSY, SSZ, and the combined. So these are like bending stresses and the axial stresses. If I just click on that option, so you can see the axial stress, shear YZ bending, and then the combination of these stresses which are given here. In this case, you again see maximum stress is at element 281. I can just go and select that and I can see the location. Similarly, I can see the forces for the truss as well. Like if you have defined any truss members, you can see the forces for that as well. In this case, like you see, all are the beam elements and there is beam and release has been used for the truss elements. That is why like you don't see any results corresponding to the same. Then comes the deformation as well. So I go to the displacement contour. I want to check the DZ. Click apply. So you have the intensity here. In case like the values are really small, you can just change the units, say to inches, and these values are updated accordingly. If you want to check the deformations for all your nodes, so you can just check here, and you can also sort it with the maximum value, say DZ. So you see the DZ values. So the maximum is on element 200 over here. Coming back to the presentation, we can also see the moving load result. So To check the moving load result, again, like under the analysis result, I will check the bending moment diagram stresses. The only difference is we can select the different cases. So in this case, earlier we were checking the results for the static loads. Now I'll be seeing the results for the moving load case. And I will check the corresponding component of the forces, solid fill, and the contour region like that. So if you recall our moving load definition, so you can see I'm having three lanes. I just display for clarity like lane 1, 2, and 3. And then we had defined the HL93 vehicle from the AASHTO LRFD. And then we have given the moving load case. In case of multiple lanes, like the number of loaded lanes, multiple presence factor are selected by that. And here if you see, I've selected the vehicle and I've given the minimum and maximum number of loaded lane as 1 and 3. That means the program will automatically create the different configurations and the combinations like two lanes are loaded simultaneously or the three or the single lane. In this case, we are having single vehicle that is running on the three lanes. But in cases you are having combination of vehicles like HL93 truck is running on lane 1 and 2 while lane 3 is occupied by some other vehicle that is say tandem loading. So what you can do, you can select lane 1 and 2, click on OK, and then again you click on add over here, select that second vehicle and the corresponding lane and click OK. So basically in that single load combination, you will have different configuration where the loaded lane are occupied by the different vehicles. Now coming back to the results for the same. So first let's check the bending moment diagram for the moving load. So here I will select the MV max and I hit apply. From the stream menu 2 I will just display the lanes like that, and I update the units to Kip's feet. So MV max, you can see the maximum sagging moment is 1114 at the element 29. So if you just select and check that over here, that is the element 29. In case you are not able to find it, like you can just activate that single one. So that gives you the idea of location, and you can also like check on the node number. As of now, I'll just activate all. So yeah. Similarly, to check the MV min, I just click apply, and here you can see like that is on element 498. Maximum hogging moment is 1439. When we check MV all, so basically it gives us both the element 114 and 1439 with the values over here. Similarly, you can check the deformations as well for the same. And you can see the intensity and the element number. These are exaggerated deformations. Like when you click on deform, here you can see like these are exaggerated. If I click on real deform, we will see it is being updated. Once you check that, now coming to the next part, that is like moving load tracer. So as of now, we have seen like the element number that was having maximum sagging and hogging. So just to showcase you again for the bending moment, we will check MV max. So element 29 was having the maximum sagging moment. Now in case you want to check the position of the vehicle that is causing this maximum moment for your bridge, so for that we will use this moving tracer option, and I choose beam forces moments. I just have to give the key element number as 29 and I click apply. So you will see the position of the vehicle that is causing this maximum moment. for your bridge in that manner and the intensity for the same. Now, as of now, one thing I would like to highlight is like when I check the results. So if we check the beam forces, MV max. So these are like not the concurrent forces, but these are actually the critical for all the elements based on influence line diagram. But at times we are interested in the concurrent results, which is caused by the maximum effect of the vehicle. And even for your bearings or your reaction supports, you might need the concurrent results. That is pretty important. So for that, we are having this right min max load to file, which is a way where we can convert this moving load into a static load to give a separate load case where you check all the critical combinations corresponding to the same. So idea here is I just click on this option, and I also have the option to choose centrifugal forces and braking forces here. As of now, I'm not choosing that, but I'll just click on OK. So it just create a text-based file like this, and we have to copy this and we go to the MCT command shell and we paste here, and I will just run it. So analysis results are like removed. Basically, it run the model with the new load case, which is this. So now you see that vehicular load that was causing the maximum effect on your bridge, that is converted into a static load like this. Now if I perform the analysis, also when we perform the analysis, so you can see in the message window how the analysis is being performed, and in case if there is any warnings or errors, and how much time it took. So it took just 5.5 seconds in this case. Once that is done, we go to the results part, and now you will be able to see a separate load case, which is a static load case for the critical effect of your bridge. And the loading, like you see, these are the concurrent behavior now. In the similar manner, you can check the reactions as well for that case. Say for the FZ. So wherever your bearings are present, you will get the concurrent results in this manner. Coming back to our presentation. So we already checked this part where I was talking about moving load tracer. We went to the results, check the moving tracer, see the beam forces, select the parts and hit apply. And then we converted it into a static load. Now next part, like once you have selected and checked all your results, the next part comes the design part for your bridge. So for that, the first thing we will be doing is the creation of the load combination. And in fact, that could be used for your results checking as well, where you want to see the results for your critical load combinations with the factors. And then you have the steel composite design being performed, and then we will see the design results. So for the load combination part, under the results itself, you will find this load combination feature. We just go here, we click on, like first we select the type of material or the design we are going to perform. In this case, we are going for composite steel girder design. Then I select that part, I choose auto generation, and after that, I have the option to choose the relevant code. So in Midas Civil NX, you will find the latest code, that is AASHTO 1120, that is available for design as well, and also for the definition of the moving load cases. So I just select that and I click OK. So we will follow this step in the program. So we go to the results, load combination. Under composite steel girder design, I click auto generation. And here you will see AASHTO 1120. Now I would like to highlight one of the important thing. At times people don't find this OK option, or like they see like the window is unable to show the value. So you will always find this kind of minimize option if you are stuck anywhere in this case. So I just select that and I click OK. And you will have all the strength and serviceability load combinations with the different factors being provided as per the code. You can always create new load combinations as per your requirement as well. Just select the load case and give the factors. Or you can also edit these one. Once this is done, like we will move towards the next part for the design. So for the steel composite design, here you will find the next tab, that is design. So if you recall, like we first started with the properties tab where we have given the inputs for material sections. Then we use the node and element tab for the geometry of the bridge. Then we use the boundary tab to give the load comment like the boundary conditions. Then load tab for different loading. Then we perform the analysis, move to results. Now we move to the design. So that is the linear approach how we proceed the work in Midas Civil. Now for the design part, I will just select the composite steel design, choose the code and choose design code option first. And I will just see all the parameters and click OK. So that is the first step to start the design. We go here. Under the design option, you will find all the different type of design that is available in Midas Civil and X. So first you can see the composite design. Then you see the steel design, RC, PSC, composite, SRC, steel ortho, deck design. So I would like to highlight, as of now we are just covering composite design, but in this case as well, if you are having your bracings as steel members, you will be able to perform design for that. And optimization feature is also available for the same. And in case you have modeled your substructure along with this bridge, so you can perform the RC design for your pier cap. You have the PM interaction curve for all those things. And even the substructure can be modeled, soil structure interaction can be performed, and you get the results and design corresponding to the same. So I select composite design, I choose the AASHTO LFD20 code here, and I just select the design parameter design code option first. So I choose update by code. You will see all the resistance factor that has been considered over here. Once that is done, I just click OK. Next part, we give the design material. So whatever kind of material we are having for the modeling and analysis part, you can override that as well for the design. But I will have to give the what kind of reinforcement sections has been used. So I'll be selecting and providing that. So in this case, we just select the A36 material and then we select the grade of main rebar as grade 60 and we click modify. I will also give the deck value, like what was the concrete strength that has been used for my deck. So for the same, I click modify material. I just select that part. And here you can see, like I am having A36 already for my slab section. I can just select the material from here after selecting the code. And same thing for my reinforcement selection. I select ASTM 19RC and the grade 60 like that. And I click modify. And this is done. And I click close. The next part is the design position. So in the bridge, you will have a lot of elements. So to perform the design, first I will select like some specific elements. You can obviously select all the elements to perform the design as well. So we will, as of now, we will select 30 to 40 elements which are at these location and just click apply after selecting the ith and jth part. Similarly, we are having the option to create the Excel report as well from the program itself for the selected element. So I will select two elements, that is element 30 and 40, that are the extreme of these elements to get the Excel report for the same. So proceeding for the step, we go to the design position. Now to select the elements, I can just give the value over here 30 to 40, press enter and you will have the elements being selected. I will choose I and J both and I click apply. Now for the output position for design output, I select that. I can just select 30 and 40 and I click apply. You can just check the tables from here by three dot option like that. So these elements has been selected. Once that is done, we will define the further inputs based on longitudinal reinforcement. So for that we go to the longitudinal rebar under the same part and here we select the section and then we give a guideline like what is the effective cover for our rebars. Accordingly, I will give the number of rebars that are to be given and the diameter and the part, and then I click add like this. So I select it. So I delete this one. I will give the guideline as 0.15. From the input method B, I select it in this manner. I give the number of rebars, give the diameter, and choose this as part 2, and I click add and I click apply. So it has been provided to your section. In case you are having multiple sections, you can use this copy reinforcement too, and you can copy it to other sections as well. The next part is the laterally unbraced length. So for the brace, like we can see what is the spacing of the bracing, and accordingly we can provide it over here. So in this case, to check any distance between the two nodes, we are having the option. If I press F4, you will find this query option. So I just use that, and I just have to select the two nodes. So I know these are the two bracings. You can see the dx distance is 20 feet here. So to provide that, I was under the design tab. Under the design parameter, you will have this unbraced length. So I'll give the laterally unbraced length as 20 feet. Now this value has to be given to all the girder elements. So under the section tab, I will select the section corresponding to my girder like this by double clicking, and I click apply. Another thing I would like to highlight, like since I was using this work menu, I would like to highlight if I want to activate only my girders, I can just right click and click active, and you will see only the girders like this. Same thing goes for the bracings as well, like this. And if I want to activate all, I just use it from here. You can also select by window, and it works like a CAD software, like when you drag from left to right, all the things that is coming inside the window will be selected. When I drag from right to left, all the intersecting elements will also be selected. I can select it and I can activate using this part. So for longer bridges or like complex projects, it is really useful. Like you can only work on specific part just by selecting that. It is easier to visualize and then assign some boundary condition or give some loads. So we have given the unbraced length. Next part comes the transfer stiffener. So I will be giving the details for the same. So for the transfer stiffener, again, we will just select the transfer stiffener from the design parameters. I select the section and then I provide the information like what is the strength of my section that has been used and what is the pitch and the dimensions for the same. So that will be given for the bearing stiffener as well, and the transfer stiffener like at the web and also at the bearing location. I'll be giving the values. So under the design parameters, here you will find the transfer stiffener. We just select that. I select the section. Now you will see the web stiffener first. I select the value. I will give the intensity. So you can choose the intensity directly by choosing the section like that. And I give the pitch, the breadth, and the value. It gets updated like that. Similarly, I will give for the bearing stiffener as well. In this manner. And after defining, I click apply. So once you select this action, you will see like it has been checked on with the details. Next part comes the shear connector details. So again, under the design parameter, you will find the shear connector as well, and you can give the values corresponding to the same. So just to check with the values, So from here I can see the pitch and give the values. So I select the category, then I give the value of the pitch, 7 inch, then height as 6 inches, dia, then the FU. One thing I have to do, important thing is like if you see the units here, it is inches while here it is feet. So we have to update the units first. So if I update the units, you see the parameters has been changed. So it is important to cross check that. After giving all the details, I will just select the section again by double clicking and I hit apply. You can just cross check the value has been given. Once that is done, like we'll then perform the design for the same, like we have given all the parameters and everything here. So then I have this option to perform the design. So I just click on the option and you will see under the window option. Once it has been completed, first you will be able to see the results in the form of result table at these location. So if I check flexure, so all the elements that you have been selected, you will see the results for the same and the ratios for the same. Then you check for the shear as well. So you can see here, like in case like it is not passing for some criteria, you can see like it is highlighted in the red color. So you can just get the detailed report of the same and then understand what was the position reason like it was lagging. As of now, I can see the stresses are a bit on the higher side. Like that is why it is like in the red color. Basically, the idea here is like once you get all the results like that, then you can perform the Excel report design for the same. So as of now, since we saw element 36, so what I will do, I will just select the design output position. So basically the program will plot the Excel report with all the details that has been like analyzed and checked in the program itself. And it has code wise results shown in the design part. So here you go. So earlier I would say like this is another improvement from the post-processing part. Earlier it took some more time to create the report in Midas Civil, but now you can see like the report creation and the post-processing part speed has been improved till 40 times. And here you see like I select the AASHTO LRFD code for the design part. So accordingly you will first get the details and then you have all the checks corresponding to the clauses and representing whether the check was correct or not. In case any criteria has not been satisfied, it will be shown in red color. Now, important thing with this is like as of now, you see like this is a standard report as per AASHTO LRFD. But as we know, a lot of DOTs or some states has their own amendments like Caltrans or Pennsylvania. So the idea here is even if you want to supersede any of the clauses from AASHTO, you get this design report, and on the parallelly you can have the more clauses like that supersede some initially created clause from the LRFD. So it will be easier for you to cross check and like upgrade this design report as per your criteria. And that is something like can be automated as well. with Midas API feature that I'll be describing in the coming webinar as well. And another thing that you can see here is like we are having this M connector. So it is something which helps you to import any kind of images or the tables from the program itself. I'll just give a glimpse of the same to give you an idea. So basically, it has to be connected to your Midas login. And once it has been done, you can see like you have the result images and the tables that can be imported. So to give you an idea of the same, like let me just create, go to the app, API settings, and I copy this. So basically it is connected now. And now idea here is I will just show you for one image. Like if I want to use this image in my report, I just click on this option. So this will include the images or any kind of tables that I want to extract. So this is another way to use the API. That is one feature, like I just showed you the glimpse, and it will be more discussed in the upcoming webinar. Then talking about the results. So here we were seeing the clauses. Again, if I went to 36 I member, then you can just check the results over here for strength serviceability. So here you see like it is minimum negative flexure concrete deck reinforcement. That was not like coming properly. If I just increase the cell sizes, it will show me correctly. So yeah, ARS which was given is less than this. So that is why it is not good. So we have to increase the flexure reinforcement for the deck for the element 36. So that is how you get a thorough design report from the program. Similarly, under the design part, if you want to perform the design for any RC design as well, so as I mentioned, you can use this RC design option. Select the concrete section and then perform the design for the same. It can be done for your column as well and for your beam as well. Apart from that, for the steel design, if I select that, I first have to create the combination as well for the same. So under the steel design, I will also use the auto generation option like I did for the composite design. So it has the combinations. Now if I want to perform the design, we go back over there. And we have this kind of thorough design report for the same. So you have the members and then you see the values, like what was the category and the ratios for all. Center ratio and the tension strength. So it is something like for that you can also optimize, as I mentioned, like steel optimal design option is also available. So it will highlight you what were the sections that can be upgraded or economized. So with this, we'll conclude the session. Thank you everyone. Now we will be taking Q&A. So feel free to write any questions that you are having from the past session as well. Like we answered a lot of questions from the last session as well through emails as well. But you can let us know whatever doubts or questions you are having. We will take up those now. Thank you.
Hi, everybody. I wanted to hop back on before we start answering questions for anybody who missed the first part of our session. We will be having a more in-depth presentation on April 30th at 3 p.m. Eastern Time. We will be going over some of the features that Mihir presented today, but more in detail, as well as some other new services and features that we will have available. So I encourage everybody to join. You can join scanning the QR code on the screen, or you can also go to the chat box and sign up using the link there. I'll hand it back to Mihir so we can start the questions. Thank you.
Mm. Thanks, Lucy. So I see one of the questions from Hui. Is it possible to have the Excel design report with cells including its formula? So as of now, like the Excel report that you see, it is text-based report, but obviously you can include your own formulas in that. And as I mentioned with the API sheet, that is something like you can easily do now because the Excel report that we have been using today was like text-based generated. But in case you are having your own Excel which is having formulas and you want to extract the results and perform the design for the same, then you can do it with the help of API. So it is something like that is now available with the Civil NX feature, and you will get a lot of more like material and the details for the same in the coming days. Thank you. I see some questions asked about the recording. So as answered, like we will be uploading the session as well, and you will get the recording. So I have another question. Does the Midas also check the AASHTO constructibility check? How does it model the overhang brackets and the screen machine loading? So yes, the program perform the constructibility check as well when you are doing the construction sequencing analysis. As you might have seen, like it had the option for the constructibility check as well. Talking about the overhang brackets and the screed machine loading, so that is something you can apply as a formwork loading or like any temporary loadings during the construction stages. So when we define the program like the model from the wizard, you have the option to give some additional loadings during the stages. So either you define it in that way, or also once your model has been created, you can give it as a static loads under the and like by going under the specific construction stage and defining at that location. So that is applicable and available, I would say. Thank you, Said. Will we get presentation PDF also? So I believe like our team will share the presentation PDF file as well to the attendees. If you insert many vehicles as a moving load, can you display the maximum moment for every vehicle? Yes. So in case your single load combination is having multiple vehicles, then it will give you the result for the vehicle that is causing the maximum effect. It can be combination of both the vehicle or individual as well, depending upon how you choose it. But in case you are having separate load cases with for each vehicle, then it will give you the results corresponding to each load case as well. And that will answer your question. Like in case I'm having 5 vehicles and I've created 5 load cases like the load combinations, so you will get the results for all the each vehicle in that manner. Thanks, Anita. Does Midas have capabilities to perform composite design when deck and beam model as shell elements yet? So in the program, like you might be aware, like we are having the option to perform the composite design when it is defined as the frame elements. For the plate elements, you get the results and you have the virtual beam results, so it can be extracted out. So this is important feature, I would say, because it is something like a lot of users has been asking about the plate design. I know. So basically with this API, again, what we will be trying to achieve is like you extract all the design results from your program itself as the virtual beam element and perform the design externally with connecting with Excel API VBA. So that will be available in that manner. As of now, inside the program, the design is not available for the composite shell element. Thanks you. Does it perform stage construction check, that is partial deck width used for live loads? Also, does the program also perform moment redistribution as per AASHTO? So the stage construction check, that is partial deck width used for live load. So that is available, like you have the option to perform that. The partial decking can be availed while defining the construction stages. Talking about the moment redistribution as per AASHTO. So here the program is running as per finite element analysis. So whatever kind of connections and the element stiffness is present, the vehicular load is divided based upon that. As compared to AASHTO live load distribution factor, so it doesn't use that. And the moment redistribution is also not done in that manner. Is the seismic design based on AASHTO force based method or it is AASHTO displacement based method? So it is as of now AASHTO force based method, but we are working with the AASHTO displacement based method as well. Like you might be seeing some webinars that we are having from the same philosophy, like talking about these design approaches. But the idea here is the displacement based method can also be achieved in the program. Like you have the definition of hinges, you have the capabilities to give the different like the moment rotation hinges curve. So the displacement based method can also be availed in the program. Thanks. Will Midas provide some libraries and instructions for implementing API into analysis and design tools? So yes, like we will be giving some instructions and like a kind of documented form as well to get started with API that will be available. And we will showcase that in the webinar as well, like where you can avail those things. And apart from that, like we are also making some plugins. Like API is definitely a useful feature, but we are making some plugins as well at our end so that API is available for all the people. So as of now, like just to give you an highlight, we are having a plugin that is based on series load generator. So it is something that helps you to perform a moving load analysis in the form of static load incremental analysis. Like when we are having set of static loads being run on a bridge. So that is how you can get some plugins be useful for you. Concerning my last question, if I have many vehicles, for example, 2 lakh, what is the best way to automate it? So if you're having like 200K vehicle, I'll have to think about it a bit. Like, I don't know, like I've never come across that situation, like 200K vehicle. But yeah, the idea here is again, you have to define it in that manner. But in case you are having some fixed format for your vehicles, then you can automate it using Python coding or like also automate using the VBA. Because now since program will be connected to OpenAI. So if you want to have any kind of automated features, that is available. So maybe you can write us more about the specific situation that you are like having. So maybe we can build a like case study for the same thing. Thanks. Does the program provide the demand capacity ratios for all the bridge elements? So it gives you the demand capacity ratios for the the different elements, and also for the auto wind and seismic and snow load determination. So for the wind load, like it is not automated, it is something like we give manually. While for the seismic, it can be given automatically, like you just have to select the different response spectrum functions. There are inbuilt AASHTO specific response spectrum function present. Accordingly, you can define that. And again, for snow load determination, it is something you have to calculate and then manually apply it using the element load feature. Is it possible to mesh the beam without using divide options? So this beam member will stay as a one member, but it will meshed. The additional nodes will be added. Thank you. So whenever there is some node defined in between the element, it will divide it. But in case you want to check the results in the mid location or ith or jth location, that is available. So is there any specific reason you don't want to divide the beam element like for this part? Because the idea here is for a finite element analysis program to run to get the accurate results for any at any point you need to have a node being defined. Or even when we are having a beam element, it actually like recalculates the intermediate results for the same. All right. I think we answered all the questions. If you have any other questions, like a minute or two is left, so you can let us know, and then we will conclude the session. If the beam is divided, then the calculation lasts longer. It is harder to do any changes. Okay, understood. So in that case, I would say like obviously you start with a mesh size that is not like too big, and for specific areas where you see like there might be required for more finer analysis, there you can divide the elements. But the thing is, at times, the thing that take time is the moving load analysis, which was your question for. So I will just show my screen to highlight one part. Right, yeah. So I was saying like when we go to the analysis option under the moving load, since your analysis is taking time, so you can check off some of these options. Like in case of moving load results, if you don't want the results for all these part, like say you just want to check the forces and moments, you don't want to see the displacement elastic link results for the same, and you don't want the concurrent results, so you can check off these options. So it will save you a lot of time from the analysis point of view. So in case of your initial analysis being done, you can use this approach that will save you some time. How does the diaphragm cross frame design in Midas? Does it perform frame analysis or shell analysis? It actually depends on how like we are defining the elements. As of now, if I'm giving the beam elements, it will be considered as frame elements, but you can finer mesh that using the plate elements. So it depends on what element I'm giving in the cross bracings, but generally I will use the beam elements for the same. All right. Okay, with this, like we will conclude the session. Thank you everyone for joining us today, and we will have a lot of exciting webinars, and please attend the webinar of M collection that we have shared the link. It will be really important thing or useful thing that you will find from that, and see you next time. Thank you. Have a nice day.